So, uncertainties are really common and really important. So we're going to need to put a number on uncertainty. Now that's a rather strange concept, putting a number on what you don't know. Certainly a concept beyond most economic forecasters and politicians. So how do we do this? Well, if we've got some variable that is going to have an integer value, for example, the number of photons detected in a given detector time, or the number of elephants in this room. So it's going to be 1, 2, but not 4.653. In that case, we can just have a list. We could say number of elephants and probability. 0 elephants, there might be, I don't know, 45% chance. 1 elephant, there might be a 15% chance, and so on. Or you could draw it as a histogram. So you could have number of elephants and probability, and so you might have 0 elephants, quite a high probability, 1 elephant, a lower probability, and then some other histogram that looks like this. Now that's very good if you have integer results, but in practice a much more common situation is where you're measuring not something like the number of something, but say a length or a mass or a continuous variable, one that can take any value, including fractions. Now for something like that you can't really do a table, because all the possibilities is the mass of an elephant 101, 102, 103, 101.1, 101.106492. There are basically an infinite number of real numbers, in fact an infinite number of real numbers just between 1 and 2, and so you can't possibly list them all and have a table. And even if you did, the probability of having any one of that infinite number of real numbers is going to be infinitesimally small, because what are the odds of it being exactly 1.07654934561, whatever it might be, as opposed to 0.00000000001 more than that. Very, very small. So we need a different concept, and that concept is the probability distribution function. And this will be a curve, so we have the probability density against whatever it is we're trying to measure, which might be the mass or the length or some continuous variable, and we'll have a curve that might look, I don't know, might look something like this. Now, the area under the curve is going to be 1. And what you want to know is, for example, what are the odds that we'll get a result that's, say, between here and here. So let's say that was 46 and that was 48. What are the odds that it will come out between that? And those odds are just the area over here. What are the odds that it lies in these values? Well, there the curve is rather higher, so the area is going to be bigger, and so the probability is larger. And the total area under the entire curve must add up to 1. So that's a probability density function. It's a curve, and it tells you the likelihood of having a number in some range is the area under the curve in that range. The odds of getting an exact number, for example exactly this, let me draw it in black so you can see it, that's the area under there. If it's an exact number, that's just a line, has no area. But you could ask, what are the odds of having something sort of vaguely in that area? In that case, it's a finite area, and you can work out the probability.